Okay, so I'm probably going to start here a little early because looking around, I see there are a lot more than 50 people, which is about as many chairs as there are that can actually fit here. So thank you everyone for dropping by here right after the lunch hour, and welcome to the presentation on best practices for mission critical apps on Azure App Service with your host, me, Stefan Shakow. So you've probably seen me before. I work on App Service. I've worked on it for quite a few years. And what I'm going to go over with all of you here today real quickly is using 4 critical features on App Service, which when you use them in conjunction with each other, you will end up having a better performing app, and your customers will have a better experience accessing your sites and your APIs. So I'm going to go over 4 main things. I'm going to go over local cache, deployment slots, app init, and the minimum sort of recommended app service plan configuration. Now, local cache is something that a lot of folks probably haven't heard of with app service. In a nutshell, it's a feature whereby we will go out and automatically copy your website content from our remote file shares and automatically distribute it across all of the virtual machines that are in your app service plan. Deployment slots, I'm sure a lot of you are very familiar with. You probably use it heavily every day and every week. It composes nicely with local cache and app init, which is why I call it out here. And I'm also going to walk through a little bit of a demo using swap with preview, which is sometimes called a 2-phase slot swap. App init, if it sounds like a familiar phrase to you, it's actually a feature that came in IIS quite a few years ago in Server 2012, and it is a way that you can tell our platform one or more URLs that we should go ping to warm up your app. And so that's a way to get us to exercise long-running cold start paths and have them run ahead of time without your customers actually encountering them. And then I'll touch on it in a few minutes why we also in general recommend for critical apps on App Service that you run with at least 2 instances. Though note, and I actually called it out in the abstract, as a service we do give you a 99.95% SLA even if you're running on a single instance. But nonetheless, if you want to avoid cold starts, you will want to be able to run on 2 or more instances. So with that quick intro, I'm going to jump over here to my laptop. And let's take a look at the sort of the sample app that I'm going to use to simulate the scenario that I'm trying to avoid here. So this is just the old MVC starter app, and I've intentionally taken the about path and arbitrarily told it that it should go sleep for 10 seconds the very first time the path gets hit. And so that's just meant to sort of simulate like, hey, I've got an app, it does a lot of stuff on startup. It may not necessarily do that all in app start. It may do it on arbitrary pages or URLs inside of your app. And the goal is to not actually have that latency ever be seen or visible by your customer. So the first thing that I did here is in my web config, I configured the app init feature. And the nice thing about this is I can give IIS and the platform 1 or more URLs that we should go ping on your behalf. So what I'm saying here is, hey, when you start my app up, I want you to go out and ping the root of my app, and I also want you to ping this home about page, which happens to be the path that has that 10-second delay. And so the idea is, hey, can we do a little sleight of hand where we sort of warm up my app off to the side and incur that cold start hit while my live production traffic is actually going somewhere else and doesn't actually see that startup. So that's what the demo app is set up as. As you'd expect, I've already got it deployed up here into App Service, and I've got one version that's running right on a URL here, that's my production slot, and then I've got a second one that's running here in the staging slot. And so the first goal here is, in essence, I'd like to have the staging version of the code here, which is really simple, the green color, and I'd like to have it swap over to the production slot, aka the blue color. And I'd like to be able to pull that off without anyone actually running into this 10-second startup delay. So let's hop over here to the portal, jump into deployment slots, and let's kick off a swap operation. Now, instead of just doing a regular swap, though, I'm going to intentionally pick swap with preview. And like I said, this is optional, but it's a very cool and it's a very powerful feature in App Service. because when you do a swap with preview, what we will do is we will take your staging slot, we will apply the production version of your app settings, your connection strings, things like that. We will apply it to that new version of the code that's sitting in the staging slot, and then we'll stop. And at that point, you can jump in and you can test out your new code exactly as if it's going to be running live in production. But all of your customers, they're still going to the production slot, so they have no idea that you're looking at this preview version of your site. And if you decide there's something wrong, it's no problem. You just cancel the swap. Again, your customers have no idea that that's going on. So let's go out and kick off the slot swap. And even though, again, here I'm showing this through the UX, realize you can also use the CLI or the PowerShell to do the exact same thing that I'm clicking through here in the portal. So while it's running here in the background, and it'll say that this really means that it's submitted the slot preview operation, but it isn't actually complete. I know offhand it's going to take about 30 seconds or so to prep that staging slot. So while that's going on, I'm going to jump in here to my app settings and walk you through a number of the other configuration values that you'll want to set up. So remember I mentioned a few minutes ago that we recommend using local cache. The way you turn on local cache is with these two app settings, this website local cache option and this local cache size in megabytes. So I know it looks a little funky, but always actually means turn on the local cache. And the size value I've explicitly set to the max we support, which is a little bit less than 2 gig. The reason why that second setting is very relevant is by default, if you don't set that value, we will only attempt to copy a 300 megabyte or smaller file corpus from our remote file content share over to the locally attached disks of each of our VMs. And so if you happen to be using local cache and you're saying, well, I don't seem to be getting any benefit from it, there's a good chance there's a simple reason for it. Your dub root is probably more than 300 meg in size. And so you just kick it up to the max, and that way we can handle copying and replicating a larger website content. Another very important point about the two local cache settings is notice I have them marked as what we call sticky settings or slot specific settings. That's very important because you do not want to turn local cache on your staging slot. Trust me when I say this because I've done this before by accident. What happens is if you accidentally enable local cache on your staging slot, we will happily replicate the content onto the locally attached disks. Then you'll come along and push a new version of your code and you'll refresh the browser and get very frustrated because you'll be like, where the heck's my new code? Well, it's over there on the remote file share and the old version of the code got pushed onto the local disk. So the pattern is you turn local cache on the production slot, you use sticky settings, and that way it's turned off on the staging slot. And that's why you use local cache in combination with deployment slots. Now there's one other setting here that I have. This one is only relevant if you happen to be running a .NET 3.5 or a .NET 4.7 based application. And don't worry, you don't have to remember the value. I've got it at the end of my slide deck for reference. But you will want to set this both on production and staging slots because it deals with some edge case scenarios when we do slot swaps and app domains might recycle. And again, as you know, if you're a .NET developer, when an app domain recycles, what happens? Your app starts up all over again, and for example, that 10-second cold start gets executed all over again. So for .NET 3.5 and .NET 4.7, you'll want this third value. So okay. I think that's probably everything we got to go through on the settings. Let's hop over to my staging version of my app. And you'll see here on the home page, right, I'm in the staging version of my slot, and it's saying, hey, local cache, the initialization is actually completed. Now local cache is actually running, in this case, on my staging slot. Why is that? We took those app settings from production, applied them to the staging slot, and then basically App Service is saying, here you go. You developer, go look at the app. You decide what you want to do at this point. So at this point, I think what we want to do is we want to complete the swap. So when you come in here, you have two options, right? You can choose to cancel it, or you can choose to complete it. And again, you can also do this programmatically. So that's actually really powerful. Again, I don't need to set anything else up to get this two-phase slot swap concept running and using it. So what I'm going to do now is in the background, I'm going to try to kick off a load test. We'll see whether or not that actually runs or hiccups, because I've noticed the network tends not to like me running a 40 to 50 RPS load test off of my laptop. But the idea is to generate load against my site, because when I compiled the site, I included application insights in it. And literally, that's all I did with App Insights with this web app. I just said in Visual Studio, go include App Insights, and you do like 2 settings to say, yeah, resource group and like what region of the world do you want it in. And what I immediately get for that is, well, you've probably seen it before, I get live metric streaming telling me, like, sure enough, there's load being generated on my app. And it'll also give me a readout of like all the servers that are actually carrying the load, which right now is a whopping total of 1. And the other nice thing is underneath the hood, App Insights is actually collecting all of the real-time log data of every single request and how long each request actually took to run. And it's building that up and storing that off to the side. And then just for grins, you can actually see here again, pick your favorite load test tool. This is just one of myriad tools out there for generating HTTP traffic. So I'm throwing it against my production slot. You can see I'm going intentionally against that long running URL. If I happen to get it on a cold start, I tag it with a query string value just to make it easier if I'm querying, and then I'm hitting it with 7 requests on every iteration. So that's how I should be generating around 40 to 50 RPS. So let's pop back in here into the portal. Let's see, okay, so the management plane is telling me, hey, it believes everything is done. I'll pop over here to my production app, and now when I go out and I hit refresh, I should just see it flip to green yellow, sure enough, so no hiccup, and that automatically flipped over. So it looks to me like the slot swap happened, and again, in a little bit, I'll run a query against App Insights to prove to you that there was no external request that actually got stalled out with a 10-second delay. So the second thing I'm going to roll along here and do is touch on that guidance I said earlier, where I said, hey, we recommend for mission critical apps not to run them on a single instance, but actually to run them on 2 instances. So I'm going to come in here into the portal, not do 22, we'll just do 2. And now I'm going to scale that app out. Now I know from prepping this talk before, it's probably going to take about 90 seconds or so for the scale out to complete. And the reason why is since I've got local cache and I've got app init configured for this app, our platform will do the pragmatic thing. We will first copy the website content over to the locally attached disk of that new VM. We will then locally generate the warm-up pings and go exercise the root URL and that about path that has the 10-second stall. We will wait for those warm-ups to actually succeed, and then and only then will we actually shift incoming traffic onto that new worker. And again, that's what you would want. Now, the problem we do see is frequently developers, right, they're not aware of how to put this all together. And so they will sometimes complain and say, hey, when I'm scaling out my app, I notice like my app stutters and my customers complain. And the reason why is if you don't do the app init in the local cache, what ends up happening is, hey, these new instances come up and we're like, great, VM's up, IIS is running, bam, go send traffic at it. And maybe your app comes up in 2 seconds, or maybe it's got a 2-minute warm-up path. And depending upon how long those cold starts are in your code base, your customers may end up seeing hiccups in performance, even though you're scaling out to take more load. So again, I'm going to let that run a little bit in the background there, just build up some data, flip back to the slide deck, and just elucidate a few of these points a little bit more. So local cache, the biggest thing that it actually buys you is resiliency to storage latency and performance. So one of the great things about App Service is when you deploy your content and you scale out, every single worker in the App Service plan sees the same content because we're all pointed at the same remote file share. The small risk with that is we are actually running a file server underneath the hood that mounts that remote file share. And that file server is actually sitting on top of Azure storage. And so there are occasionally latencies in storage. And also we, as the platform, will periodically update our file servers. For example, the most mundane reason, right? We need to security patch, like all of you, our servers once a month. And when that happens, there's going to be a little bit of a hiccup in access to that remote file share. If you're running local cache, your app isn't going to care. All the content's local, and your app will be completely oblivious to those kinds of hiccups. So deployment slots, I think most of you here, you understand the core concept of like, why should you use deployment slots? I wanted to show you swap with preview because that is a really cool and incredibly useful part of our platform. And the nice thing about slots itself is that it's built to interact and use both local cache and app init. So when we do the slot swap, we do the intelligent thing and we initialize the cache and do the warm up as part of that swap. So app init, like I said earlier, it's a feature that first came in IIS on Windows Server 2012. We've integrated it into the app service platform, and so we will actually ping those warm-up URLs both during slot swap as well as during scale out. And then the last piece of advice, like we mentioned earlier, run on 2 instances, because then that way we can be intelligent about when we start routing traffic onto the new instances. I'll actually give you another quick anecdote. There's another situation that running on 2 instances and all of this helps you with, right? Across the platform, we have to update the VMs, again, once a month, and frankly, the reality is on any day of the week, we are probably upgrading or updating some set of VMs somewhere in the world. When that happens, if you're running on a single instance, we're only going to give you around 2 minutes before that app shuts down and we stop routing traffic to it, and then we're just going to throw the load over to a new VM where we've spun you up. And if you aren't up and running and ready to rock and roll at that point, your customers will end up seeing a performance stutter. If you're running on 2 instances, though, we do the smart thing. We bring down 1 instance because let's say we got to go patch the OS. We keep traffic going to that second instance. Off to the side, we bring up the third one. We initialize the cache, we warm it up, and only when all of that completes do we start routing new traffic to that additional instance. So that's another reason why running on 2 instances is definitely a best practice on our platform. Last thing here, just to again sort of demystify some things that go on underneath the hood, right? By default, when you're using app service, this is roughly what the directory structure looks like. And so on this slide, I've got 2 hypothetical VMs, and each VM, the apps locally, they see a d:/home directory. In reality, through some sleight of hand, that D drive is actually pointed at the remote file share on app service. And so when you, for example, publish to your www root directory, what's going on is that's landing on that remote file share, but all the all the workers see through D home, they see that one file share. So from your app's perspective, it's like, okay, everybody sees the same code, and that's typically what you want, again, early on when you're doing development. Now, when local cache is in the picture, from the point of view of your app code, nothing changes. It still sees a D home directory, everything's fine, you don't need to change any of your code. But what will happen is when we're initializing a local cache, we will do a one-time copy of your site content and bring it over to the locally attached disk. We'll do the same thing for the site extensions directory, because if you use site extensions, that's basically a kind of code, so we make sure we copy that over. And then we start up your app, and at that point, we never look back at the site or site extensions directory unless, for example, you swap a slot again. And then while your app is up and running, we will periodically take files that are in the log files directory and the data directory, and we will copy them back to that remote file share. So for example, if you happen to be using file-based W3C logs and you run with local cache, you'll periodically see those copied back to the remote file share. All right, I'm going to hop back to my laptop now. Great, we're up on the screen, and at this point, first off, we'll double check. I'm going to assume that, yep, sure enough, the scale operation completed. Probably no big surprise there. Over here in the metric stream, well, we'll just go ahead and there we go. Click around a little bit and you see, sure enough, I've got 2 servers that are up and running, and roughly speaking, I've got a good traffic split running on them. And now to sort of close things out, I've got offhand here a query that I wrote against the logs that are collected by App Insights. So we'll go out and run that. And what that should be showing me is over the recent period of time, what was going on, in terms of requests that took 10 seconds. So if you take a look at this, I can tell you right now that cloud role instance at 797D, that's actually the new one that just swapped into rotation. You can see, sure enough, it took 10 seconds, right? I mean, that's what you would expect. But take a look at that URL. That URL clearly is not me running the load test on my laptop. And in fact, right there, that URL is the classic signature of the platform-generated warm-up pings, because they literally originate on the local host of the VM, and locally we say, hey, let's go through each of those warm-up URLs. And then let's see if I think I can probably maybe pull in a little more data if I look back a little bit more. And then sure enough, great, I've got, in this case, I can see 2 instances of calling this localhost home about, and in both cases, each of them took about 10 seconds. And again, believe me when I say that's basically one instance of it occurring on the first VM that I was already running on, and the second one is from the second occurrence when I was actually scaling out the app. So proof that we were able to incur that 10-second startup cost off to the side without the live traffic ever seeing that performance hiccup. Also offhand, I find it pretty cool that I can run these kinds of queries against the data that we collect with App Insights, because again, interesting anecdote, the underlying technology, this query language, this is actually the same stuff all of us inside of Azure and inside of App Service use morning, noon, and night. So offhand, if you're ever wondering, and you open a support incident and someone's looking into the logs, literally we're looking into the internal variation of what you're seeing right up here on the screen. So okay, just to sort of close things out, summarize everything, these are the 4 best practices. It's for the Windows variation of Azure App Service. You don't need to worry about it for small, less critical apps, but for mission critical apps, for your metaphorical crown jewels of your workloads, use local cache. I'm sure all of you are using deployment slots, but take a look at swap with preview, because that's a really great way to do that last minute test before you finally say go or no go on your code. Make use of app init. I mean, just put in a few URLs, the URLs in your app that you know are problematic, and we'll go out and warm them up for you. And then the last one, try to run in at least 2 instances, because in combination with the first 3 best practices, this will give you the best chance of minimizing any issues around unexpected cold start latencies. So that's the talk. Thank you everyone for dropping by again after lunch. You probably heard it earlier, but we are over at the web and mobile, which is literally like 20 feet that way. So a lot of folks on my team are over there. I'll be over there for most of the week. So if you've got questions about this or anything else, feel free to drop on by. Thank you again, everyone.